Diamond Plastics Corporation was founded in 1982. Since that time, our singular focus has been gasketed PVC pipe for water, sewer, and irrigation applications. In the last 10 years alone, Diamond Plastics has shipped approximately 30 million feet of PVC pipe every year. The reason for this explosion in growth is due to the superior performance record of PVC pipe, which has been used in the United States for over 50 years. At Diamond Plastics, our people take pride in manufacturing and supplying our clients with the highest quality pipe product available. We know that protecting your water resources is becoming increasingly more important, and that long-lasting, reliable pipe can help achieve that goal. Because of our decades of experience, Diamond Plastics has become one of the world's leading manufacturers in high-quality PVC pipe, boasting the world's largest diameter gasketed pipe at 60 inches. Diamond Plastics has also grown by supplying PVC pipe for industrial and municipal applications. Starting out with 2 facilities, Diamond Plastics now has 7 geographically strategic plant locations across the United States. We all use PVC pipes every day, even if we never see them. They carry water to and waste from our homes, businesses, and schools, improving the health and convenience of our everyday lives. Polyvinyl chloride, commonly known as PVC, is a durable, rigid plastic, originally invented over 100 years ago. The basic PVC resin is blended with various additives to create many strong but flexible products, like garden hoses, or, as Diamond Plastics blends it, into superior corrosion-free, non-toxic pipes. The raw materials used to make PVC come to the plant facility by rail cars and trucks. The majority of the incoming raw materials are stored in silos or rail cars just outside the plant building. Creating PVC starts with a specialized batch of ingredients carefully blended together for each specific application. The individual recipe for the PVC depends on the end application. It generally consists of the primary ingredient of resin and 5 to 8 different raw materials. In the case of Core 21, a sewer compound is used. Water and sewer pipes, for example, have similar but very different recipes. The exact ingredients and quantities vary as to which type of pipe is being produced and are created to strict industry standards. In the case of Diamond Core 21, ASTM F949 and ASTM 794. These governing standards are also used later in testing the finished product. Over the past 20 years, Diamond Plastics has invested in several technologies to improve the product options for the underground utility industry. In 2005, we made an investment into an open profile pipe product we call Core 21. Short for corrugated pipe for the 21st century. This PVC pipe has a smooth interior and a corrugated exterior wall with a gasketed bell and spigot designed to serve as a watertight, corrosion-free gravity sanitary sewer or storm drain pipe. An investment in the technology to produce this product in sizes 12 to 42 inch was made. This product offers cost savings, which are significant to some users, and allows them to stretch their infrastructure dollars compared to solid wall options. The corrugated wall construction allows the product to be produced through 42 inches. It is produced to a 50 psi minimum pipe stiffness, which surpasses that of SDR 35 PVC sewer pipe, which has a minimum pipe stiffness of 46 psi. The profile allows the product to develop stiffness more efficiently than a solid wall PVC pipe and reduces overall material use by approximately 60 to 63%, depending upon the diameter. The efficiency of a profile is obtained by moving the centroid of the pipe wall, thereby increasing the moment of inertia, which is a key variable in the determination of pipe stiffness. This results in a substantial cost savings for the end user over traditional gasketed solid wall PVC pipe. The manufacturing of Core 21 begins in much the same fashion as all of our PVC pipes do. The raw materials enter into the plant blending room and are stored in separate micro hoppers. The higher usage materials, such as resin and calcium carbonate, are stored in silos and vacuum conveyed back into the mixer system through pipes coming from the storage silo. Depending on the blended mix desired, the materials are combined in both a hot and cool mixer. Paddles and blades inside the mixer blend the raw materials together. When it is time to make pipe, the mixed compounds are then moved from holding silos to hoppers stationed above the extrusion line. The powder compound is gravity-fed down from the hopper into the extruder. Heat stabilizers and lubricants that are blended into each compound help the PVC compound move through the equipment. The extruder consists of a barrel and a precision set of screws, as well as a motorized drive system. The compound enters the extruder and is augered through the barrel by the screws, which apply compression and heat to the PVC material. The proper application of pressure and temperature turns the compound into a hot, pliable material suitable to push through an extrusion die. To begin the process of producing a corrugated pipe, two pipes are formed within the die. An outer wall and an inner wall pipe are formed through the use of a splitter which divides the flow within the die. The outer wall exits the die first, pushed by air pressure, and is then grabbed by the corrugator mold blocks. The corrugator mold blocks are machined aluminum which are precisely cut to specific dimensions to form the outside diameter of the pipe corrugations. The corrugator mold blocks have an internal vacuum which pulls the outer wall pipe into the blocks to form the corrugations. The corrugator mold blocks seat as the outer wall is formed, and a continuous pipe is formed. The inner wall pipe exits slightly behind the outer wall and is moved onto a cold plug. It meets up with the outer wall, and the two walls are fused together with heat and pressure in the valleys of the corrugation. Chilled air is pumped through the blocks and past the cold plug after the walls are fused to set the dimensions. As the finished pipe moves down the line, a saw is engaged which moves with the pipe and travels around it to cut it to required lengths. 14-foot laying lengths for standard sewer and storm drain applications. Wall samples are also cut for quality assurance testing in accordance with ASTM F794 and F949 standard requirements. Once the pipe is cut into standard lengths, it moves to the belling station. The intended bell end has corrugation relief holes drilled in those corrugations, which will be heated to prevent collapse when the bell is formed. Heated air within the corrugation must be allowed to escape during the belling process. The bell end is then placed in a heater and rotated to reheat the material until sufficiently pliable to form the bell. The pipe continues to the belling station, where it is pushed over a collapsible mandrel to form the bell. The gasket is placed on the spigot end. Because the gasket is removable and located on the spigot end of the pipe, the contractor may easily make field cuts and modification to the length of the piece of pipe without sacrificing the entire length of the pipe. With manufacturing completed, Core 21 pipes are bound together in bundles for ease of storage and transport. They are moved into the holding area for further quality assurance review prior to being placed into inventory. Quality assurance testing is an important part of the manufacturing process. Previously cut samples are used to carefully run a battery of tests in accordance with ASTM F794 and F949 to include dimensional checks for wall and inside diameter. A flattening test is conducted in which a sample is hydraulically flattened to 40% of the original OD, a deflection of 60%. Any splitting, cracking, breaking, or separation of the walls would signify a failure. An impact test is completed in which a 20 or 30-pound tup is dropped from a set height to assure proper extrusion was achieved. Any cracking or splitting would signify a failure. Pipe stiffness verifications are conducted to assure it meets the minimum requirement of 50 psi in accordance with the industry standard. A fusion test is performed by placing a properly prepared sample into an acetone immersion bath for 20 minutes. When removed, the technician looks for flaking or lifting of the PVC, which would signal a failure and suggest an improper material fusion during the extrusion process. Once the required quality assurance reviews are complete, the pipe is placed into inventory and released for shipment to various projects underway. Diamond Plastics employees load bundles of pipe on the flatbed. Then drivers tighten the straps, which securely hold the pipe load. Once all the pipes are loaded and tied down, the truck will move to the exit area of the facility. Numbers are placed on each trailer and recorded along with each load's corresponding tracking number and destination information. This system allows for reliable tracking and service to our clients. The tractor trailers haul the pipe all over the continental United States, Canada, and Mexico. Depending upon the construction project, it may require one or dozens of truckloads to transport to the construction site. Once installed, they will begin their reliable service in our everyday lives. It may be unseen, however, PVC pipe manufactured by Diamond Plastics plays a critical part in our water, agricultural, and waste management, today and into the future for all of us. Diamond Plastics Corporation, with facilities around the country, the investment in technology, people, and a quality product that's made to last.